What have you done?
I've been enjoying myself. That's what I've been doing.
What have you got going here?
Oh, we have an energy device that takes electrons that are available just about everywhere and converts them into useful energy.
Okay. Now, how do you do that?
Well, once you move them, ambient would be the background, and once you move energy away from or energy source away from the background, like moving water up a hill, it will always come down. Mm-hmm. And in the case of electrons, if you excite them, or the level of excitement is above the ambient or background, you have useful energy.
Well, how did you come up with this conclusion?
Well, when I realized that it was the movement of the electrons or the acceleration that was the principal source of the energy, then I had to develop a way to capture it or transfer it into a more useful source.
Okay. Well, what was your intention by doing this? What were you trying to do?
By doing it, what was my intention? Basically, I had heard that it couldn't be done, and all the experts told me that, and that didn't ring very true to me, so I decided I would see if what they were saying was actually true. When I realized that the components in an electrical field has an alternate component of magnetic field, and that they're equal and opposite, and that's your Lorentz or your equal and opposite EMF opposed sort of thing, and they do not appear separate. And being in the field of geology, there were electromagnetic maps which were available, which told me that the Earth's surface had a tremendous amount of electricity in it that was useful. And in trying to resolve that in regards to the activity of electrons, I realized that energy is everywhere at all times in great amounts, and that it's dormant until you disturb it or cycle it. And the cycling would be the resonant activity seen in radio devices. So you're moving electrons and you're creating electro and magnetic fields, and by being able to capture these fields at their higher levels of excitement, you get greater, you have a gradient that's greater getting back to ambient, so therefore you have a greater amount of energy.
Now, what's your background? How did you come up with all
My
that?
background, I'm a professional in science. My work history was primarily connected with petroleum industry. I have an engineering background. I'm fully familiar with all of the establishment's ideas in regards to electricity and electromechanics and physics and all the other things that relate to it, and have always had a very doubtful eye towards anything that the establishment might consider appropriate. So therefore, when people told me that this thing would not happen, to forget about it, that was the match that lit the haystack. I think it's the end of the road as far as energy goes. I think that if there are any other developments, this one is benign as far as the environment is concerned. It's very cost effective. It's something which can be all over the world. It's not something which belongs to any one individual, any one country, and that basically the effect will be the one side effect of this is it generates ozone, which it actually puts oxygen back into the atmosphere, and none of the energy methods available today do that. There's almost nothing, there's really nothing out there that you can think of that does not use this system.
Is this similar to what Nikola Tesla was trying to achieve with free?
It is a spin-off. Basically, what I have done is pick up where Nikola Tesla had reached, and I've put myself inside his mind, and I've expanded and extended what Nikola Tesla was doing.
Now, do you think you've actually figured out what he was doing?
Yeah, I can read his mind almost perfect. Actually, I did not know about Tesla until I was into this thing more than 5 years, I guess.
Really?
Yes, and I knew the name, but I had no idea as to exactly the significance of it. And people started saying, well, you're doing what Tesla did. Building the same kinds of coils and doing all the same types of things. And at that point, well, it really got interesting because I realized that there were other people out there that were thinking along the same line.
Now, you had mentioned something about James Clerk Maxwell.
Yes.
Some of the paperwork. What do you know about that?
Okay, in the case of James Clerk Maxwell, he was professor at Cambridge University, and he picked up all of the things which Maxwell did had been done previously, and he put them in a mathematical shape so that they could be described and repeated. And he's one of the fellows that I mentioned that have to have all the pieces of the puzzle except one. So anyhow, his thinking and mine are amazingly close together because I have researched and gone back to his personal thinking. The books that are out, which I have some of the original ones, original set, were put together after he died by the faculty at Cambridge University. And they reflect what was politically correct to the faculty at Cambridge University. They do not reflect what Maxwell actually said and thought.
So you're saying if he didn't have to go through the whole peer acceptance process, we would have had a different book?
Yes.
Really?
Yeah, well, what actually came out of it was not Maxwell at all anyhow. It was the faculty in the physics department at Cambridge University with what they considered politically correct. Oliver Heavisides was your EMC squared source, and it was lifted by Einstein, and I can show you exactly where Einstein got it from.
Really? Now, how much earlier are we talking here?
About almost 100, well, between 50 and 100 years earlier. Yes, most people think that I've kind of fell out of a tree, but when they realize that I've had total access to the Library of Congress, to dozens of university libraries, including here in the United States, overseas, including Italy, and Germany, and France, and England, and I've gone through these libraries like you wouldn't believe. I knew from the first moment that it was going to work and how it was going to work.
Really? Were you trying to build something specific at the time?
No, all I was trying to do was disturb ambient.
Really? Now, tell me something about these radio frequencies. I understand you're using radio frequencies to achieve this.
Well, the electron, when you cycle it or move it, you get a magnetic field and you get an electrical field. And the faster you move the electron, the cumulative effect of that magnetic and electrical field becomes greater.
Okay.
So if you're cycling at, say, 60 or 120 cycles per second, you get the same amount of electrons. And then you cycle, say, at 1,000,000 cycles per second, the curve on the increase in the amount of magnetic and electrical field there is doing this. And when it does this, and you capture it at one of the higher points, you capture it at a higher point, you get a lot more energy from the same amount of electrons than you had at the lower point.
Okay.
So this, to some people, would be would say that you're getting free energy.
What would you call it?
I would say you're getting what's there.
Just finding a new way to
you're getting what's there. The term free energy is a bastardized terminology that's used by sour grapes establishment.
use terms of the alternative?
Okay, they're all basically the same thing. They're ether, ether, atmosphere, air, or whatever. They're all describing the same thing, and it's a hula hoop mentality. It's whoever happens to be writing the book or talking at the time, and they're grasping at something which they don't really understand.
Magnetically.
Okay, in the 1920s, people discovered that in studying the Earth's crust, that it had electrical characteristics. Mm-hmm. And most people consider that the Earth's electrical field is useless or near zero. But when you actually look into it, you find that the Earth has an enormous electrical charge on it. It's just that it's everywhere about you. It doesn't vary in a short distance. So all of the instruments that are made to measure electricity are made to measure a reference point and another point. So the electrical flux, when you start measuring electrical flux or magnetic flux, which is the other side of the coin, you find that the Earth has an enormous electrical field. No, I had the conclusion before I ever started. It was what got me into it to begin with.
Really? So this is sort of what keyed you into what was going on.
Yeah, I knew that there was an electromagnetic. Uh-huh. You can't have one without the other, and it flips. And when it flips, at that flipping point is where you have your useful energy. And the more you flip it, the more you have useful energy.
Does this have anything to do with the planet running at 8 hertz or anything like that?
Well, the death frequency is 7 cycles per second. Mm-hmm. So the Earth is, depending on who you talk to, has a frequency of around 7 or 8 cycles per second. Yeah. And that's consistent. Now, if you built a device that would capture that, you would have an energy level, but it would be very low because you're not flipping the electrons that much. Now, in the other Earth's electrical systems, there are a number of them running all at one time. You have the ionized layers that are up above. They're one side of a capacitor. The Earth's crust or surface is one side of a capacitor. So you have an enormous electrical potential between the ionized layers and the Earth's surface, and you have an exact duplicate of it in the Earth's surface, because in a capacitor, one plate has to equal the other one, or else you've got discharges between them. And it's the turbulence in the atmosphere that disturbs this balance, that where you get your lightning and other electrical disturbances. So the lightning is over unity in itself. Ambient or earth ground is unity, and anything that you see other than that is over unity. So that means that lightning is over unity. Okay, everything in nature. And everything in nature is, of course, simple. So all the other things, including molecules and everything else, they all attach themselves to each other. Uh-huh. So in the case of electrons, it's unreal to believe that a single electron will be floating out here without interacting with something else. Mm-hmm. So as it turns out, there's good evidence that some electrons have more negative charge than others, and that by being more negative or less negative, that's the same as being plus or minus. So therefore, the electron with a weaker charge will attract one with a stronger charge, and they will be orbiting in each other, and they're relatively easy to pull apart. So the electrical and magnetic charge of the electron, of course, when you spin them right, you get a magnetic field. When you spin them left, you get an electrical field. Okay. So when they spin apart, you're getting a benefit of both of those, and then whenever they come spinning back together, you're getting the volts and the magnetic field coupling again, which means your amps times volts equal watts, or you've got useful energy. Well, actually, this thing remakes the entire world of energy. It's a very simple supposition, and when put in force, it creates a world in which there's no pollution. It creates a world in which there are no not-haves.
Mm-hmm.
All of the political systems are on equal standing, so you don't have a reason for war. So that saves a lot of lives. And it also puts ozone back, or oxygen back into a useful form, which also will save a lot of lives. Okay, this is the state of Colorado.
Okay.
And the colors on the map represent levels of electromagnetic energy.
Okay.
And you can see there's quite a diversity.
Okay, now what are all these colors here?
Okay, the dark blues are extremely negative. The reds are the lower ranges of negativity. The contour lines on there, each contour represents about 5,000 volts difference in the electrical field.
So what would this be used for normally? Why would somebody take a
These were originally used by the United States government in looking for radioactive materials during the Cold War.
Now, how did you come up with the idea of looking for these?
Well, they have been used for locating oil and gas deposits since 1920.
Okay.
They've been used since 1920 for locating oil and gas deposits.
Okay, now, why do you use them? What are you looking for with these maps?
Why would I normally use them?
Yeah, I mean, what would you be looking for?
Basically, about 10 years ago, I had reached a level in the petroleum industry where my salary was too much, and I had too much experience, and the people that were in the company all had less, and they felt uncomfortable around me. So suddenly one day I found myself without a job. This has to do with the frequencies which things move at whenever you get into resonant energy. Resonant just simply means that you're flipping the electrons. And this is the electromagnetic chart that was worked up by Westinghouse, and can be purchased through the Edmunds Scientific for $11 in case you want to buy one.
So this is
or the Exploratorium out in San Francisco, which is they're the people that had it put together by Westinghouse.
Now, what does this have to do with your technology?
It shows the cycling or the frequency, radio frequency. It starts at say 0 cycles per second and moves up through the various frequencies into the gigahertz, and then it goes on even beyond that. So Farnsworth, for example, was the person who actually invented the television tube that we have today, and he did that in the process of working with the exact same type of thing which I'm working with. He had to build the television tube itself is an over unity device.
Is it?
Yeah, it's an offshoot of a dynode and a number of other things. And a dynode basically is where you have in a radio tube a cathode, which is the input side, and you have an anode, which the electrons move from the cathode to the anode. Okay, in the case of the dynode, you have alternate anodes in here, which this thing is bouncing off of, And if you have a certain type of material on these anodes, one electron leaving here and bouncing to this one knocks, say, 50,000 electrons loose, which bounce to the next stage, which knocks 5 million electrons loose, which goes to the next stage, which knocks 50 million electrons loose, and then the anode here collects them, and you have 50 million times the amount of electrons active here that you had here. So you have gained 50 million times what you started out with.
So it's some kind of multiplier.
It's a multiplier, and it was renamed by Farnsworth, called a multipactor, and basically he was using like a radio emitting substance here. Mm-hmm. You have this same thing in a light detector in cameras and other things, which open and close the shutter based on the ambient light. Mm-hmm. A small amount of light hits a cathode, which knocks some electrons loose. Mm-hmm. And they start bouncing through the dynode system, and they end up being enough electricity to operate the shutter in your camera. So you have an enormous amount of output compared to the input.
Interesting. Is there anything else you'd like to say about this?
Well, the same thing applies in changing frequencies here. The same amount of electricity inserted at a lower level raised to a higher frequency will disturb more of the electro and the magnetic field, which at that point you capture, and you have a huge gain over what you put in.
Fantastic. Okay, well, so that does fall right into what you're talking about.
So you have not violated any laws of physics, but you have an enormous amount of energy that you did not have to begin with.
What do you call it when you capture this wavelength? Do you have a name for it?
When you capture it?
Yeah, like obviously...
Well, you can temporarily store it in capacitors, batteries, coils, or various other systems temporarily, and then you can convert it to some other system that is useful to the device which you need to power.
So the energy just doesn't tear around wildly?
No, it's not just running all over the place. Yeah. Sometimes it gets loose in the form of sparks or spacks or whatever.
Is this over here?
The devices which I have invented, which there are a number of them, they all actually accelerate electrons.
Okay.
They're electron accelerators, and one of the outcomes I might mention of the multipactor thing which Farnsworth had, which is a over-unity device without question, is the magnetron in your microwave oven.
Okay.
So all patents are related to magnetrons, multipactors, dinodes, and all related patents are over-unity patents.
Fantastic.
And there's no way to deny it. If the person has any, even slight degree of intellect, they will know immediately that that's the case.
So this has been sitting in front of us the whole time?
Yeah, it's been here since 1920s and 30s in grand form. Before we go to the other devices, this is a component which shows up on some of the devices. Okay. And can you read the reading on it?
Give me just a moment.
I'll bring it even closer if you want so that you can actually read it. The reason I want you to read it is because calculate the input which the manufacturer specifies.
Okay, go ahead.
And then calculate the output which the manufacturer puts on there for that same amount of voltage. And you'll see immediately that this thing is putting out more energy than it was put into it.
So
the manufacturer actually states the input and the output, and it's on the label, and they have tested it, or they would not have put it on there.
So it exists.
Here's an over-unity device looking right at you. Okay. And there are a lot of them that are that way if you bother to calculate the input and the output.
Great. Okay. What is this?
Okay, this is one of many devices which I have built. I would say one of several hundred. Uh-huh. And this is one of the sort of intermediate ones.
Okay.
And technology present here is largely 1800s.
Uh-huh. And well, what is this here?
What is the device?
Yeah, what do you got here?
It's a resonant electrical energy generator.
Well, what does it do?
Basically what I do, I take a low voltage at 12 volts at about 7 amp hours from a battery, and I run it through the device. The first thing I do, in order, the high voltage module here has to run off 120 volts. So since I'm intending to use a 12-volt battery, I have to bring the voltage up so that the high voltage module can run.
Okay.
So this is an inverter here.
Okay. And this is just a Radio Shack part.
Yeah. It's everything you see here except these. Most anyone could get, and these. Now this and this. Unless you get them from me, you don't get them.
So these are your homemade ones here.
Well, they were special made for me.
What are they? Can you give me an idea?
Well, these are 10,000 volt capacitors.
Wow. And what's the
this is a 9,000 volt high voltage module that is similar to the little one that I showed just a moment ago.
Okay.
And this is from the same people. This is about 6,000 volts, and this is 9,000 volts.
Okay.
This is essentially a solid state device, and so is this.
Okay. So how does it go here?
Where does what go?
Where does it start?
Okay, it comes in here.
Okay.
And comes from a 9-volt battery.
Okay.
There's a cord that's calculated to a certain length because it's a frequency that works with it's a quarter wavelength of this coil here.
Okay.
The physical length of the input from the 12-volt battery. And the reason for that is that it will recharge the battery if it can communicate with the radio frequency magnetic field that's in the area.
I see. So it's just constantly recharging.
Yeah, the magnetic field from what's going on here will recharge the battery faster than it's being discharged.
That's great. Besides that being
how do I know that? If you take a light emitting diode, electricity can only flow in one direction in a light emitting diode. Take two of them and reverse them and make a pigtail and put them in the line that comes from the battery to the device, and depending on which one's lighting up, you know which way the electricity is flowing.
Okay.
And when they're both lit up, you're taking out and you're putting in at the same time, and the reason you can do that is that they're different frequencies. Okay, we've got 12 volts coming in. We have a kickback diode here, which prevents a kickback from the inverter to the battery.
Okay.
And we also have on the input where the 12 volt comes in, we have this pigtail set of light emitting diodes, which tell you that you're charging your battery at the same time that you're using it.
Okay.
And once we get past that point and get into this inverter, this is 9,000 volt high voltage module, which would be, it's a version of a Tesla coil, except it's a solid state version.
Okay, okay, that makes sense.
It does the same thing as a Tesla coil, except it's solid state version of the same action.
Yeah.
So anyhow, in order to control that, since we don't want to use the full 9,000 volts, I have a neon tube transformer control here, which controls the amount of the 110 volts that comes out of this into this.
Okay.
I can use the whole 9,000 volts, or I can use any part of it. And the reason I have to cut it back is because what's over here cannot take what's over here. Well, I'm going to end up with a lot more voltage than I can manage.
Well,
so I have to reduce it. It's easier to reduce it on the low end. Once it gets to the high end, you have trouble, special equipment, and a lot of trouble varying it.
Okay.
So I vary it on the input on the low side.
Yeah.
Okay, I get to the high voltage module, and on neon tube transformers they have two output wires. So I have to take the electricity that's on the two output wires and put it back together as one source of electricity. And then I have to pump it through the L1 coil and then back into the system. And then I have the capacitor bank here in order to help regulate that.
And that's, I'm sorry, you said that was 100,000?
No, these are 10,000.
Okay.
Or maybe 15, I don't recall just at the moment, but they're more likely 15.
Okay.
But they were done special order by Cornell Dubier for me, and they were free.
Well, that's nice.
Because most of the companies like that have a department where they will make up samples for you if you're doing research and development, and you need something which they don't have in the catalog. They will make them up special for you, and that's exactly what happened here.
Really?
Okay, once we get to the, this is the broadcast end of it, or the part that sets the electromagnetic field into oscillation.
Now, how do you do that? Is it sending a radio wave through it?
Well, it's when you pulse something, and you pulse it through a coil like this, a magnetic field builds and collapses.
And that's all you
And it's a collapsing, building and collapsing off and on that spins the electrons. The magnetic field and then the magnetic field off, and they'll spin back to where they were. So you've got the coin flipping with the electromagnetic component flipping. And once you've got it flipping, then you're in business.
So that's the whole trick to this. Is just
yeah. Once you've got it flipping, then you've got to have something to collect it with. And then the rest of this is the collector and storage part.
So what do you have, just a couple of capacitors there? And
no, those are, there's 8,000 volts worth of capacitors there.
Are those special made?
No.
Really? What's the little tube on the end there?
Which one?
So the little yellow...
the yellow one?
Yeah.
Okay. That has a double meaning. In this case, it has no meaning because I've already charging the battery from over here.
Oh, was that used to...
But the energy coming from here before it goes out to the transformer is passing through this one, and that's building a magnetic field. This one is not connected to this one in any way except through a magnetic field. So this becomes a generator of electricity, and you can charge batteries from that.
That's great. That's a great system. How much energy would you say this little system could produce?
This one? What's the output on it?
Yeah.
It's about 16 kVA.
Great.
Which is a lot of energy.
Yeah. And that's
it could go higher than that. That's with this thing turned down on low.
Wow. Now, does it, like, run itself out?
No, there's nothing here to wear out.
Wow. So there's no...
the capacitors are self-healing.
So this is it. You've got a closed-loop system that charges itself and kicks off enough energy to...
once it's going, it's on its own. No, this is sort of an intermediate model.
Yeah.
And there's a larger one sitting over here, a more commercial type. This one actually, the one in the suitcase calculates out at about, I put in the book a little article I gave you, I think it was 27 kVA.
No kidding.
It's about half the size of this.
Wow.
So this is capable of probably around 50 kVA.
Now, is this something that you give away as far as selling plans to people or showing people how?
Well, the plans for some of these things are in the publications.
So this is not any great secret. This is out there.
No, it's looking people in the face. A commercial model, and the absolute output level on it, I don't know, but some of the components in there would probably limit it to about 35,000 volts at probably about 200 amperes. and that is an enormous amount of electricity. So you can see that it has the same components that the other device has. They're just scaled up somewhat.
Have you used this one here?
I've had it. I've started it, and I know that I've tested it, but I haven't ran this particular one for any extended period of time, except to just start it.
So this was just sort of an experiment to see if you could build it commercially?
Well, basically, it was just to see how the components fit on the board. Was what it was.
Great. Because
I did the schematics and passed them on to other people, and they're building them.
Okay. Great. Use that on this device?
Actually, I'm going to show you how to make a simple one.
Okay, great.
Most of the things that are in my devices which I demonstrate were put there because people expect to see them, not because they need to be there.
Okay.
Okay, so this device, which I had turned upside down. Okay. Great. Is the high voltage module here. So we come out and we need a L1 coil here. That's going to be our L1 or input coil, and we're going to run this. Since this is alternating current, it's neither plus or minus. It's going to be what it's going to be doing is coming over here and into here and coming back just like that. So we've got our high voltage device and we've got an L1 coil, and it's all working just fine. At this point it's running at 35,000 cycles per second. Okay, and we don't, the method I'm teaching you here, you don't have to know about tuning. The fact that the length of the wires that go on this coil here are basically irrelevant because it's being pumped by the high voltage device here, and that's going to set the frequency. The length of the wires are not going to have anything to do with it. So you don't have to know how to tune it to do this. Okay, the next thing is that we're going to have an L2 coil here, and it's going to have coils on it, and it's going to be out, and this is going to be your minus, and this is going to be your plus down here at the bottom. And electricity or electrical field always moves from the highest of concentration to the lowest. But in this case, what's happening is each coil there has a capacitance and inductive characteristic. So it's magnifying. For example, say that this is 3,000 volts here, and we have 10 turns here. So this is volts, and we have 10 turns. Okay, we divide 10 into 3,000, and that means that each turn is going to equal 300 volts. So each turn on a L2 coil here, each turn on there will have 300 volts on it. So if you have 30 turns, you've got 300 times 30, which would be, let's see, 300 times 30. Okay, and that's going to be 0, 0, 0, 9. So you're going to have 9,000 volts on your L2 coil. Okay. Okay. It's going to do that irregardless of the amount of turns or the frequency or whatever. What we're doing by forcing the 35,000 cycles per second onto this first coil, we're forcing that second coil to duplicate the same thing as long as it's an even division of or multiple of the wire length in the first coil. Okay. So we've got, at this point, we've got 9,000 volts out, and we probably will want to put a spark gap of some sort in here so that we can, and this goes to your earth ground. Okay, this center part of the spark gap will go to earth ground.
Okay.
Okay, and this is going to limit the voltage so that it's within the range which you can handle it with whatever device you're going to load this with.
Okay.
So you can go directly from this into your transformer out here, and it'd be an isolation transformer. And at this point, what you have to do, since you've got a frequency which the isolation transformer cannot use, you have to correct the frequency. So in order to correct the frequency, you put a resistor across the two poles there. In order to determine what resistor size you use, you go to either the American Radio Relay League chart showing capacitance and resistance and other types of things, which will tell you what approximate frequency you'll end up with. Now, in the case of American Radio Relay League, you're going to be off the end of the chart, and you're going to have to take a little piece of paper and make the grid and extend the chart over about an inch or so and about an inch or so down in order to get, say, 60 cycles or 120 or whatever it is you want. But you can do that real easy.
Okay.
So anyhow, we've got through our 12 volts, and none of the electrons from the 12-volt battery have left the high voltage module. The high voltage module has excited electrons in a separate, just like your transformer here, where you have the two sides are separated from each other so that none of the electricity on this side actually goes through the system. And what it does through induction, it excites the coil on the other side, and your electricity over here is coming from the earth grounding, and your load is going to be in between the earth grounding and the other pole of that transformer. And you're going to have to also put some sort of voltage control on this thing here, and that will be a varactor, V-A-R-A-C-T-E-R. And what that is, like on your computer where you have a voltage control thing that keeps the spikes from coming in, it looks like a little capacitor, but it's not.
Okay.
But it basically will limit the voltage to some level which is okay for the device that you're trying to run. Now, what I have shown you here, you don't have to know how to tune it. That takes care of itself for you, and you have to make only one correction in the frequency, and any coil and resistor or any coil and capacitor or any combination of those will give you a particular frequency. Now, Radio Shack has a book on electronic tables and such, and you can use the charts in it.
Okay. Is this the smaller, simplified version?
No, there's some solid state versions of this where all of this is thrown out. But I'm not at liberty to talk about them just now.
But this can give somebody an idea that you don't actually have to come.
You don't have to know what you're doing at all.